Hello, everybody, and welcome to this webinar on the hidden data economy, which is proudly brought to us by Oracle. Really happy to be here. My name is Charles Ross. I am the Asia Editorial Director at the Economist Intelligence Unit. And really looking forward to delving into this really great topic around the hidden data economy. And to help me do that, I've got some great speakers with us today. The first is Paul Sonderregger, who is the Senior Data Strategist at Oracle. And he'll be talking a little bit later about how we can better create value from data. Later on, Andrei, who is a leading expert on platform strategy, will be talking about how companies can create competitive advantage from data. And right at the very end of the session today, we'll have a discussion, which will take us up to the 1 hour. So please do stay with us through to the end and that lively discussion. First, I just want to talk a little bit about where we are in this sort of history and development of the data economy, and it actually quite nicely reflects my career here at the Economist. One of the very first projects I started back in 2013 was one which looked at the data, or looked at big data analytics, and essentially the extent to which companies were understanding what it was and adopting it. And that was really at the very peak of that inflated expectations on the Gartner hype cycle. If you're familiar with that cycle, it shows that we were at that point where there was a lot of hype and excitement around big data, but no one was really getting too much value out of it. And we were about to dip into that trough of disillusionment, which we have sort of gone through and are starting to come out of it now. And one of the other data points which came out of that research was that some 54% of companies in Asia hadn't even started using big data analytics, which is really quite astounding to think about when you scoot forward to 2017, when we really saw that the whole industry and the collection of data had spiraled in a very, very big way. We featured this as one of our key stories in The Economist, where we were one of the first to declare that the world's most valuable resource was no longer oil. It was now data, because of the value that it can bring companies, industry, and the wider society. And that sort of deluge of data which came about then was largely driven by the huge array of different ways we were now able to collect it, whether it's from going out for a run or watching TV or just sitting in traffic. Pretty much everything we were doing in 2017, we were able to capture the data about what we were doing. And so today, that deluge of data is continuing at a really quite astonishing rate. Places like China are driving this collection of data with some 40% increase, year-on-year increase in the amount of data which is being collected. So again, we continue to cover this topic at The Economist, and just in February this year, we had a whole special report which focused on this. A couple of articles in there, one which is around the deluge of data, which is giving rise to a new economy, and another one which looked at how integrating data is getting harder, but also more important. We're going to touch on some of those points on the webinar today, but I also know that Oracle has made these articles available to you, so I do encourage you to read them if you get the chance to do so. And I know Paul contributed quite heavily to those as well. But recognizing, like you, like us, we all are a little bit short of time, I'm going to give you a couple of the key findings, takeaways, which came out of that special report. The first is that we tried to sort of put an estimate on the value of data and the value it would have to an economy. And so we looked at the US, and the figure we came up with was quite an extraordinary one, which was somewhere in the region of $1.4 to $2 trillion in the US alone would be the value of the data economy. And that is equivalent to nearly 5% of America's stock of private physical capital. So we're talking about quite an astonishingly large amount of value coming from data. It's a very big number. Here in Asia, where I am based, I'm speaking to you from Singapore today. China is the dominant power. And as I said before, they're leading the race in terms of the increase in year-on-year collection of data. But with so much data, getting value from it and finding this sort of elusive digital truth, and for those who are not familiar with that concept, it is about identifying and combining data that accurately represents reality. And that's becoming much more difficult with the range and type of data and the speed at which it's coming at us is happening. Some things are helping us get on top of data and creating insights from it, and AI is one of those, and many enterprises are infusing this into their corporate applications. But to do this, they do need to change the way they operate. They need to reorganize and manage their data. And they're doing this by turning more to the cloud. The cloud has always been a really great enabler of data analytics, with most of that demand for hyperscale data centers. It creates more flexibility for firms. But these data centers have their pros, but they also have their cons. They also cause sustainability problems because they do consume huge amounts of energy. And there is a certain amount of privity risk which is associated with that as well. So we are seeing, because of some of those challenges, but also just because of the huge data deluge which we're in the midst of, some sort of decentralizing counter movement of the way data is processed and where it is processed, and that's moving us closer to the edge where we can process and collect data a little bit closer to where it's being produced and where it's needed, rather than a continual reliance on these very large hyperscale data centers. Finally, online giants assume that the data economy will be very much a global affair, and to some extent it is a global affair, but that's becoming harder and harder and trickier as we get a lot of data localization laws coming into place. Things like GDPR is making it difficult for global giants to move and shift their data around the world. And here in Asia, we're seeing a really large disparity in the types of ways that governments are treating data, whether it's in Singapore or Indonesia or the Philippines. So this sort of complexity around data sovereignty is quite challenging for companies to address as well. What we are seeing from a company perspective now is that in response to this real explosion of data, they are expanding their collection and analysis of information. So we're very much not at that peak of inflated expectations, which I mentioned on the first slide in 2013. We're very much at a sort of a proactive approach to companies and working on this. And they're tapping into new data streams that help them better understand their internal performance, including the records of companies' employees, job descriptions, employee performance goals, with measurable outcomes, company goals, and quarterly results. And now we're exploring this at the moment in a great piece of research that we're doing with the Oracle, looking at the data-driven enterprise, and that's going to be published shortly. But one of the sort of interesting data points coming out of that is that when we look at companies and we're asking them, are they making optimal use of their digital technologies within their organization? Many of them say that they are not. They are not making use of these properly. So they have the technologies, but they're just not using it in the most effective sort of way. So a lot of motivation to do this, but still more skills, more sort of support is needed to give companies get the most out of this deluge of data. Finally, just to talk about the COVID-19 impact on data, and it's clearly having a significant impact on all of our lives, and we've been tracking this obviously very closely at the Economist, and you can see sort of the progression of the pandemic through the covers we've got here. But it's also been sort of mirrored a little bit with the way data has been sort of used at each stage through this pandemic. And so right at the very start, when we saw that it was very much a sort of a China-focused challenge for them to deal with, we found that the data, they used a lot of data, along with obviously a lot of other measures, to really help them flatten down that curve. We know that China collects a lot of data. They have a lot of control over that data. And so they were able to use that data to be able to track, control, and help them sort of more rapidly flatten that curve. And we're seeing that play out today. There are of course, some skeptics out there that say that we should be questioning the very low numbers they have at the moment and the data around that data. But by the looks of it, they are using data in a very effective way to do this. As the pandemic went global and the virus went global, we are seeing an unprecedented sharing of data, and particularly and most encouragingly amongst healthcare professionals and healthcare systems around the world, where we're seeing a very active sharing of data to help, in the first case, find a better way of testing, better way of treating, and now, of course, a lot of the focus is on finding a vaccine to get us out of this. And so, encouraging that that's happening, and it'll be interesting to see sort of how sticky that global sharing of data will be going forward. We shoot forward to March 21st, and this is the point where many of those major economies, in the West, in Europe, and in the US, then were forcing companies to move their business into the digital realm. And of course, that's really playing into the data deluge, and a huge amount of data is being created as we're all working remotely, we're speaking remotely. This webinar is another good example of data being collected, and there are many cases of this happening around the world. And so it will be interesting to see if we looked at again at those data deluge numbers, to see how the increase in data collection has been impacted by COVID-19. I'm sure we'll see a big uptick on that 40% year-on-year growth that we saw coming from China in particular. So just a bit of background. I now want to get into a bit more detail and get into the nuts and bolts around the hidden data economy. And I'm going to start first with Paul, who is going to provide us some more insights. Andre will come next. And then, as I said again, we'll have a discussion at the end. So please do stay for that as well. Thank you, Paul.
Thank you, Charles. It is true. There is a hidden data economy inside each large organization. But most companies don't think of it this way. They should, because by having the supply, the demand for data in their firms and the transaction costs in between obscured, by not being able to see that hidden data economy, it is probably underperforming. So the question then becomes, how do you bring this data economy into the light so that you can see and manage it more effectively and increase the productivity of that data economy? And that's what we're going to look at here briefly. And the place to begin is with this central concept that data is a kind of capital. And now when we say this, when we say data capital, this is not a metaphor. This is not like data is the new oil, or data is the new gold, or data is the new electricity. What we're saying is that data fulfills the literal economic textbook definition of capital. So unlike a natural resource, capital is a produced good. It's something that you have to invest to create. But more importantly, it is an input into other goods and services. It is what economists call a factor of production. If you don't have that factor, you can't produce the thing you're thinking of. So, for example, if you design a skyscraper, but you lack the financial capital to pay for the construction, you can't have that skyscraper. By the same token, if you design, let's say, a differential pricing algorithm or a recommendation AI, but you lack the data to feed it, you can't have that service. Data is an economic factor of production in digital goods and services. Data is a kind of capital. So, as the economist has described, data is in fact an asset, even though modern accounting rules still won't allow firms to put it on their balance sheets as such. That is the way that it behaves. That is the way that data functions inside an organization. So, but if it is a kind of capital and you can't account for it in that way exactly, well, what kind of an asset is that? Well, it turns out the data is a curious asset, and so we have to think about its economic identity. And so, here is a description of this reality from Eric Brynjolfsson, the director of the MIT Initiative on the Digital Economy. He says that computing hardware used to be a capital asset, while data wasn't thought of as an asset in the same way. Now, hardware is becoming a service people buy in real time, and the lasting asset is the data. So this notion that data is actually a kind of asset is spreading far and wide, but it is a curious kind of asset. And if we look at its economic identity, we find this set of attributes that you don't find mixed together in any other kind of asset class. So data is a non-rivalrous asset. And what that means is that multiple parties can use the same data set simultaneously. So a tractor, for example, is a rivalrous asset. Sally can drive the tractor, Bob can drive the tractor, but they cannot both drive the tractor at the same time. However, data, a single data set, can feed multiple applications, analytics, and AIs simultaneously. Data is a non-rivalrous asset. The next important characteristic, though, is that it is non-fungible. And this is very different from normal commodities. So with a normal commodity, say like oil, you don't care if you get barrel A or barrel B. They have the same energy content. They're going to behave the same way in the refinery. One barrel is substitutable for another. Those barrels are fungible. Data is not like that. So one data set will contain signals about, let's say, lunar cycles, the observations of the moon. Another one will contain observations about birth rates and death rates in a particular town in Europe. These two data sets are not substitutable. They have completely different signals. And this one, the one with the lunar observations, Newton used to back up his development of the calculus. And this data set about the birth and death rates, Sir Edmund Halley used to figure out how many fighting age men Britain had to wage the 9 Years' War. Two different data sets, totally different signals. They are not substitutable. Data is non-fungible. The third crucial aspect of data's economic identity is that it's an experience good. You don't know what it's worth to you until after you use it. Now, other goods are like this. Movies are like this. They're an experience good. So Shutter Island, for example, sounds fantastic. It's Leonardo DiCaprio, it's Scorsese, it happens in Boston, and it is fantastic until the last 5 minutes when you find out that it was just a dream sequence. You're never going to get your time back from watching this movie, even if you could get refunded for what you spent on it. It's an experience good. You don't know what it's worth to you until after you have experienced it. Data is exactly like this. So this combination of characteristics, non-rivalrous, fungible, and experience good, this makes data a curious kind of asset. But even these aspects are not the strangest characteristic of data. The strangest characteristic of data is that most of it never goes to market. Now, we know that some of it does. We know that some data gets bought and sold, and there are crucial security and privacy implications and practices for the buying and selling of data. We'll talk a little bit more about that. However, the vast majority of data never goes to market. It gets used by the same firm that creates it. So most companies are capturing observations about their own activities. They're capturing observations about their interactions with their customers, all of this coming from applications, sensors, devices, and then they use that data in digital goods and services that they themselves create. This is the engine, the major engine of value in the real economy for data, for value creation from data. And what this means is that inside the four walls of every large organization is this supply of data and demand for it in order to do something with it. And it's hiding in plain sight. So let's look at this hidden data economy a little more closely. Within the four walls of a firm, you have this supply of data. Data is being created, minted by applications, sensors, devices, in an ever-growing variety of formats and in ever-growing amounts. So a growing, diversifying supply of data sets. And then you have demand. Primarily from analytics and AIs, although of course applications do read from this supply of data, so they also form some of this demand. But primarily we think of it in terms of analytics and AIs that want to chew on this data in order to improve decisions and actions. So you've got supply from, on one side, growing in amount and in diversity, and then you have the same thing on the demand side, an ever greater number of analytics and AIs with an ever greater variety of models chewing on this data to create value from it. But of course, this is not all happening in one single computing environment. Enterprises create data and then use it in on-premises facilities, local cloud, public cloud. And so most large organizations have this complicated hidden data economy. Supply coming from multiple different app sensors and devices in multiple environments, and demand for that data coming from multiple analytics and AIs across a variety of environments. But what really makes these data economies underperform in most organizations is that companies simply don't think of them in these terms. So what can you do? What can you do if you are a large organization that wants to start thinking in terms of supply and demand, the transaction costs between the two? What can you do? You're not actually going to ask your departments to start buying and selling data to each other. That's highly unlikely. And you're inside this kind of command environment where you're not really going to have competition for data sets. You're not really going to have market signals in terms of prices for data sets and different uses. So what do you do? Well, at Oracle, we think there are three things that you can focus on to bring your data economy into the light and to help it grow. And those three things are data liquidity, data productivity, and data security. And so we'll look at each one of these in turn. So first, data liquidity. So data liquidity is the ability to get data from its point of creation to its many points of use efficiently. This idea is built on the notion of market liquidity, where what you want to see for a given equity, for example, is lots of buyers and lots of sellers. That makes it very easy to move, to buy and to sell this asset, to pick up a whole bunch of it and dispose of it. So this is what you want with data. You want somehow this growing amount and diversity of data sets to be easily, quickly transformed into the shape and structure necessary to use it, to feed it into these, for this variety of models and AIs. You kind of want your data to be a shapeshifter so that any given data set can be created in the format and structure that that app, sensor, or device demands for its performance, and yet can be available through the access methods that any analytic or AI would like to use to get at that data, as if it had been created for its purpose to begin with. And it sounds a little magical, but it's not. It actually is achievable. This is the vision behind the Oracle Autonomous Database. This is why Oracle is creating a family of autonomous technologies, and why the first one was the database itself. So let me just give you a couple examples. So one of the ways that you can achieve data liquidity is to build an application that, let's say, is doing puts and gets with JSON documents. And so for those of you who aren't familiar with JSON documents, this is the most common data structure for all of the mobile and web apps that you use on your phone. These documents, they have little fields within them, but each one could have a slightly different structure. And so they don't really lend themselves well to being put into a table, a single table, because each one of these documents has its own structure. That's really good for the application, but it's not good for analytics. And so normally what you'd have to do is move that data from the database that you use to support your application, and you put it into another one to support your analytics, and you got to do this whole transformation of the structure. But instead, with the Oracle Autonomous Database, you write the data down as JSON files, and then you access it as if it had been built in tables for analytics to begin with. Now, inside the database, there's a whole lot of artificial intelligence that makes that work, that takes the burden off of your shoulders of figuring out how to achieve that kind of liquidity. But that's just one example. Another example is in the case of analytics. We have some customers who are using the Autonomous Data Warehouse, where they have some questions, some queries they know they're going to ask of the data that they have pre-modeled in that data warehouse. But then they have new questions that come up that need to be answered by data of some other structure that's outside the warehouse. It's in an object store. And so with the Autonomous Data Warehouse, that query can be applied to that warehouse. And then the Autonomous Data Warehouse passes the piece of the query that's answered by this other set of data outside of the warehouse to where that data resides, in the object store. And you don't have to know anything about this. So these are examples, early examples of this larger vision that Oracle is executing against, one where you can have a data platform that both absorbs and delivers data of any size and shape for the task at hand. So this is the first key point in bringing your data economy into the light, is reducing the time, the cost, the effort to get data from its point of origin to its many points of use. Now, the next idea is data productivity. And here, the real focus is in getting data into AIs and analytics embedded in business processes and decisions. Because the fact of the matter is that data doesn't create any value until you do something with it. Up to that point, it's just generating costs. So data has no intrinsic value of its own. It can only generate revenue or decrease costs when it is being applied to a process or a decision. And so one of the things that Oracle has been working on is embedding lots of AIs into our enterprise SaaS applications. So for example, within an HR application, a next best candidate AI that reduces the time and effort required to go through resumes, for example, and improves the fit between candidates and available jobs. Another embedded AI is in credit evaluation. So should you have a situation where suddenly you need to change a whole bunch of suppliers, and you really need to do fast evaluations of their creditworthiness, this is something where embedded AI in that decision-making process would save a lot of time and potentially reduce quite a bit of risk. So this is the second idea in surfacing your data economy. It is making it easier to use the data assets you've built up in embedded analytics and AIs in business processes and decisions. And then the third main area to focus on is, of course, data security. And so here, what we're focusing on is increasing protections for both the observer and the observed over observations. So in this world where data is a kind of asset, there are multiple stakeholders for that asset. Data that is derived from interactions with consumers, for example, will have personally identifiable information. That data is increasingly governed by an overlapping patchwork of regulations, depending on data residency, depending on, in some cases, the citizenship of the person you're observing as a company. So if there are multiple stakeholders now on these data assets, security means providing protections both for them as well as for the organization that is then processing that information, using that information to make sure that they are remaining compliant. And so here's where, just as an example, we're building services like DataSafe, which can profile data, identify data that conforms to the definitions of sensitive information according to different regulations, and flag that for you. Also, automatically identify misconfiguration in databases, like creeping, like privilege creep, roles that have privileges that are above what they require. That is a common kind of security flaw. In addition, the Oracle Cloud is infused with AI through services like CloudGuard, which is constantly watching the behavior of all of your workloads in the Oracle Cloud and using machine learning methods to tell the difference between the normal behavior of a logged in user with legitimate credentials and highly anomalous behavior of that user logged in with legitimate credentials, because maybe those credentials were stolen and a bad actor is now inside your system under cover of a real person's identity. And so these are AI services that can identify that kind of behavior. Because even in an environment where you are trying to reduce the time, cost, and effort of getting data from its point of creation to its many points of use, it can't be a free-for-all. All of that value-creating activity has to happen within the guardrails of compliance and of risk management. So these are the three big areas we think companies should be focusing on to bring their data economies, their hidden data economy into the light and to help it grow. And if you do that, there's one big implication that follows from this that I just want to call out, and that is data trade. The buying, selling, and barter of data with protections for all stakeholders. And we're seeing just the very early days of this, but let me just give you some early indications of where this is going. For example, there's a small startup in Germany called Retraced, and they have built a service that allows brands to highlight their fair trade practices through their entire supply chain by putting onto a blockchain documents that verify the practices and policies of all of their suppliers. And so clothing brands, for example, can verify that their suppliers run workshops where they are paying living wages. One of the really interesting implications of this idea is that what Retrace has found is that some of those suppliers now recognize that they can distinguish themselves by revealing this information. And this echoes an idea that Michael Porter at the Harvard Business School wrote about a while ago called shared value. That by increasing transparency through verifiable data capture, it becomes possible for players deeper in that supply chain to capture more of the value for themselves. This is the kind of possibility that opens up in a world where there is data trade with built-in protections for all stakeholders on top of a platform that increases data liquidity, increases data productivity, and increases security. So with that, Charles, let me hand it back to you.
Excellent. Thank you very much, Paul. Really fascinating. I love the way that you sort of magically describe the data as a shapeshifter. I think it's a really nice way of thinking about it. Just want to touch on one of the points you made. You've talked quite a lot of detail, sort of the technical solutions around how companies should be managing data to get better value out of their internal data. But just want to think about from an organizational point of view, how do you think companies do need to structure themselves to be able to, from a personnel, from an operational perspective, from a people perspective, to be able to reduce that time from when the data is created through to when it is being the point of when it's being used and getting value out of it? Sure.
Well, we're seeing some of this kind of organizational change and process and culture change in the technology world in the form of DevOps. And so, for those of you who may not be familiar with this practice, in ages gone by, you used to have a development team who would build applications or build an analytical environment, a warehousing environment, and then throw it over to an operations team to run. And things don't work like that anymore. Instead, now you see lots of IT organizations following the example of startups who adopted a DevOps model, where the development team runs the service that they build. And this is both an organizational change as well as a culture change, as well as a process change. But the net effect is to put into the same hands the creation of data, the minting of data, and a much closer observation of how that data is being used in that application. The next part is then to make that data easier to use in analytics and AIs. And here is where this notion of data liquidity really has a big impact. Today those organizations are really separate. Those organizations that create data and those that use it, they tend not to talk to each other a whole lot about why the data is created that way, why the data gets used that way. But in a world where you can have multiple access methods to the same data and have different parties get a different lens onto that data, in fact, have it transformed from one shape and structure to another, that's when you get an environment that's going to facilitate a lot better communication between those different groups.
Makes a lot of sense. Thank you very much. I'm going to move on to Andre now, because obviously one of the reasons why most companies, or a lot of companies, are trying to get more value out of their data, their internal data, is to gain a competitive advantage within the marketplace. And so, Andre, I can hand over to you. You're going to provide us a bit more insight into sort of how you're seeing that play out in industry.
Sure. Thank you, Charles. Let me know. I just want to make sure, are the slides showing properly now?
Yes. All good. Thank you.
Right. So, like you mentioned, I will take this a level above. So I'll be talking about how data can be used to create competitive advantage, which obviously is the ultimate goal here. I don't know how much, so a lot of the times people use the phrase, is data the new oil? It's not necessarily a very happy phrase, but I think at least it points to the fact that data can be a very valuable resource. And in particular, what's happening now, a lot of companies have access to data from their customers, and the idea is by getting more data from our customers, we can improve our products, and therefore we can get more customers. Now, this is happening for a range of products, starting from relatively sophisticated products like enterprise software, but it's also now going into very mundane products. So I listed a few examples here. Some of them are hilarious. So for example, there are yoga mats. There are companies today that claim that they can improve the experience that their customers are having with their yoga mats using data from their customers. So clearly there's a lot of appeal for startups and large companies alike to claim that, we have a lot of data. Therefore, that leads to this virtuous circle that I'm showing here. And more customers lead to more data, which in turn helps us improve the products. Therefore, we get more customers. And that basically means we're going to beat all of our competitors. Now, to a certain extent, especially for people that have followed the startup world and venture capital since the early 2000s, that looks a lot like network effects. So network effects, the idea is like the more customers a network has, the more valuable the product or the service is for each customer. So this would be something like Airbnb or Facebook. The more people are on Facebook, obviously, the more value there is. So the cycle, this virtuous cycle with data looks very similar. And the conclusion that a lot of companies, a lot of investors draw is that, well, because of this virtuous cycle, that necessarily means that as soon as we have data, this kind of data-enabled learning where we learn from our customers and improve our products, that absolutely necessarily leads to competitive advantage. It should be relatively obvious that a lot of these claims typically are either exaggerated or plain wrong. So I've actually grown very skeptical in recent years of all these claims that somehow data-enabled learning necessarily leads to strong competitive advantage. And by the way, this has also been true with network effects. There have been a lot of inflated values where startups were claiming we have network effects, therefore we're worth $1 billion. And a lot of those claims turn out not to be correct. And I think what we're seeing today is the exact same thing with data. And again, this is true for both startups and for established companies. So the key question here, again, is asking if I'm, for any company of any size, if we do have data-enabled learning, well, under what conditions does this kind of data-enabled learning actually lead to defensible competitive positions? And what I'm going to try to do here relatively quickly is to talk through about 6 or 7 conditions that have to be true in order for a company's data-enabled learning to actually create competitive advantage. Before I dive into the specific conditions, I think it's worthwhile to take a step back and think about what has changed. Why is this obsession with data-enabled learning more of a recent phenomenon? So the first observation that I want to make is that there have been businesses built around data for a very long time. Now, what I call here traditional data aggregators, so these are companies like Bloomberg or credit bureaus, this is not data-enabled learning. This is not what we're talking about here. These companies were built basically on very large data sets that they spent a lot of capital acquiring from very different sources, and then they license access to their customers. That's a very different type of business than the ones that are what's happening today, in which companies are basically constantly monitoring or extracting data from the use of their products or services by their customers. This is, of course, happening because there's increasing penetration of cloud. There's a widespread widespread adoption of cloud-based services, and the fact that we can put chips in pretty much any product. And this allows companies to glean a lot of data, very useful data from their customers, to very, very fine-grained levels. So, it's not just I can get data about a lot of customers, but I can also get very fine-grained data about individual customer behavior. And obviously, that opens the possibility to improve products and to actually even personalize products to a degree that was never possible before. So, the speed and scope of gathering data from customers is truly something that has accelerated a lot in recent years. So that was not true before. Of course, companies have always tried, even traditional consumer goods companies have always tried to learn from their customers, but that process was very slow. They would have to do surveys, they could maybe do survey 1,000 customers. And typically what they learned from their customers was only possible to incorporate those learnings in future generations of the product. Another key thing that's happening right now is companies, especially say software companies, they can improve the product while the consumers are using them. So you start using a product, and then actually the product gets better as you're using it. I mean, that's truly something novel. And of course, it is true that to a certain extent that this possibility does allow some companies to gain a lot of competitive advantage by actually iterating very fast on their products. So maybe to use a a very, very current example. Think about video conferencing software. So there's a reason that Zoom has progressed tremendously and has emerged as a leader in the past couple months in the video conferencing market. A lot of people, a lot of companies are using it. A lot of customers are using it. They've been iterating a lot faster than most of their competitors, and that's certainly enabled them, to actually gain some competitive advantage. We'll see how sustainable that is. All right, so let me now talk about the conditions under which data, in this context, data-enabled learning actually leads to competitive advantage. So this would be just a list of questions. I think it's 7 questions, and I'll just briefly explain what they mean. It should be relatively intuitive. The first and the very obvious one is, well, how valuable is the learning from customer data versus the standalone value of the product? So I'll give you an example here. Everyone uses Netflix, and I guess everyone uses Netflix a lot more these days because everyone's stuck at home. Well, Netflix has this very nice algorithm which recommends shows to their users. And, they've actually made a lot of publicity about how good this algorithm has become, how well it learns from your usage. That is absolutely, so that is very true. It's, it's certainly useful. But if you step back and ask yourself, do I subscribe to Netflix because of the recommendation algorithm, or do I subscribe because of the library of movies or TV shows? The answer is, I don't think a lot of people subscribe just because of the quality of the Netflix recommendation algorithm, which suggests that in this case, while data from customers is very valuable to Netflix, I don't think it actually adds all that much to the value of the Netflix service. So this is an example in which, yes, sure, they have data, it's relatively valuable. I don't think Netflix is necessarily in a good competitive position just based on the value of that data. And in fact, actually facing increased competition from Disney and a lot of other services. And of course, there are other cases like, say, Mobileye, which provides software for not self-driving cars, for driver assistance systems. Well, in the case of Mobileye, the value of the learning from customer data is a lot higher. The second one, so this was about the total value of learning. The second question that I should ask is, well, what about the marginal value of data-enabled learning? So what I have in mind here is how much does the product improve with additional data from customers? There's some circumstances in which the value of the service of the product keeps improving a lot as you get, even after you get 1 million or 2 million customers. In other cases, the value of the data actually plateaus very quickly. So a good example is Google Search. Google Search is the dominant search engine, and certainly it will remain so for the foreseeable future, mainly because the more customers and the more searches they serve every day, that actually allows them to improve the product. Still today, even though they have billions of searches, they have access to billions of customers, billions of searches. Now, the opposite example would be something like Nest, which is smart thermostats. Certainly, Nest uses data from its customers to improve the product. But I would argue that in the case of Nest, while data is useful initially, they don't need that much data in order to basically reach the maximum amount of data learning that can be extracted from there. So it's probably sufficient to actually have Nest at home. After 1 or 2 days, Nest has pretty much learned anything that it needs to learn from me. So basically, the value of the data is exhausted relatively quickly. So obviously, the implication is if the value of the data is exhausted quickly, it's probably not something that will provide long-term sustainable competitive advantage. The third one, which is closely related, well, how quickly does the relevance of this data depreciate? So in some cases, the data that you accumulated 5 or 10 years ago is still valuable today. So I would say in the case of Google Search, certainly every year the search trends might change, but the fact that Google powered billions of searches 5 years ago, they're still probably learning something from that. In other cases, data that you have from 5 years ago is completely obsolete. So what really matters is data about today's customers and today's usage. Well, in this latter case, it's a little bit, you actually have to work a little bit harder to maintain your competitive advantage, because it means someone can come in and accumulate data about customers today, about their current usages, and they're not at a disadvantage by the fact that they were not there 5 years ago. Fourth factor, which is pretty obvious, and I think this touches a little bit on what Paul mentioned, is our data proprietary or unique? I don't need to explain this. I mean, it should be pretty obvious. In a lot of circumstances, companies do have data, but that data is neither unique, so it's data that all their competitors have access to, or it's not proprietary. If that's the case, obviously it's pretty hard to sustain competitive advantage. The fifth point is, well, even if the data, let's suppose the data is proprietary and unique, what really matters actually is not the data itself, is what you do with it. And for example, if I have a product, I have a lot of proprietary data from my customers, but the manifestation of that data in my product, so let's say I can build better features due to the data that I get from my customers. If those features are easily observed and copied by my competitors, again, data was valuable, but what I do with it is not so valuable and it doesn't allow me to sustain competitive advantage. So in those cases, again, just having the data might not be enough. The last 2 points are very important because this is where I will come back to the notion of network effects, which is so critical. For some reason, a lot of companies, actually for good reason, a lot of companies, a lot of investors are obsessed with the notion of network effects. And I would argue it's understandable. So it's the idea that if I have companies or businesses that have network effects tend to have more competitive advantage than others. There's this like self-reinforcing feedback that you get with network effects that you would also like to get with data. So sixth question is, does the data from one user help improve the product for the same user or for other users? Well, this is basically getting to the point that if you have a larger customer base than your competitors, you're actually going to learn more and you're going to learn faster. Now, in some cases, in most examples, I guess, of data-enabled learning, this might be true, but I will give you at least one example of a product in which the data is mostly helps the company improve its service for the same user. So I use a music service in the United States, which is called Pandora. And actually, so Pandora is very popular in the United States. Think of it as a competitor to Spotify. Now, if you go out of the United States, no one's heard of Pandora. Everyone uses Spotify. Part of the reason, and what's interesting about this, Pandora was the first to market with internet radio and highly personalized internet radio. So part of the reason I love Pandora is because I've listened to it for like many years now. They've learned my preferences. They're able to predict and recommend songs and stations that I really like. And I'm very I love it. I don't want to switch. The problem with they're certainly using data. They were actually the company that pioneered something called the Music Genome Project, in which they break down music a little bit like the human genome, and they're able to use that in order to create a very sophisticated database that then allows them to provide these very clever recommendations. It's awesome. The problem with that is, again, it's very good getting users hooked onto their service. So getting someone like me to absolutely love it and to stay with them for a while. It's not that helpful for getting new users. So this is where Pandora diverged from Spotify. Spotify was much better at basically allowing people to share playlists and basically have network effects across multiple users, which basically allowed them to grow a lot faster. And this is why, again, today, if you go outside the United States, there's no Pandora, but Spotify is pretty much in every single country. So this is an example in which having data is very valuable. So Pandora, certainly created a lot of value. I think they were sold to SiriusXM about 2 years ago. But the issue is they were not able to grow as fast as someone like Spotify, which actually was able to improve their product using data across many, many different groups. And finally, the seventh point, and this I think is critical. This is what is truly different today from using data in previously. Is that in a lot of cases, in some cases, the insights from data-enabled learning can actually be incorporated in products very, very fast. Now, the faster you're able to incorporate the data insights from your customers into your products, obviously, the stronger your competitive advantage. So I'll give you two examples here, two contrasting examples. Think about Google Maps. Part of the reason Google Maps is so valuable is obviously it learns from many different people. So it learns from people driving in different parts of the town, figures out traffic, and make great recommendations. So it certainly answers yes or no to question number 6. Now, from the perspective of number 7, the answer is also, well, they learn very fast because it's almost instantaneous. They're able to adjust traffic and recommendations based on live data. So certainly, like any insights they can get from the data gets incorporated into the product and improves the quality of the product almost instantaneously. Well, in other cases, so there's a number of companies now that provide lending online, and they use data from other customers to better refine their offerings. So certainly the answer yes. They're certainly using data-enabled learning, and it certainly satisfies the criteria number 6. The problem here, though, is that the data that they learn from the customers today is not very helpful to the same customers. If I go to LendUp or to Lending Point, the offer they're going to make me is going to be based on offers that they made to previous people last year. But I don't care how many other people Lending Point is going to serve today. So this is very different from Google Maps. If I use Google Maps, I do care how many other people are using Google Maps because it gives me a better service. In the case of Lending Point, I really don't care. So again, there's a big difference here in the sense that data can incorporate much faster into the product, allows the companies to improve faster, and therefore does allow them to sustain competitive advantage in the future. And this, to me, this is why these questions 6 and 7 are critical, and basically answering the question, well, does my data-enabled learning, does it actually create network effects? And if the answer is yes, I do have a much higher chance of gaining competitive advantage. In the interest of time, I'm going to skip to the concluding slide, and maybe I want to leave some time for questions, Charles. So first thing I want to say is I think data-enabled learning has become accessible to more and more companies and to more and more products today. It's just, again, the increasing reliance on cloud computing and the fact that we can put chips on pretty much any product or service, miniaturized chips, makes it possible even for the most mundane products to actually learn from data. Like I mentioned, this doesn't necessarily, this is, I think, the biggest leap of faith that people make is just because we have data-enabled learning, that absolutely means we have a very valuable business. That is just not necessarily the case. More likely what will happen is that data learning will become table stakes, and in particular, if everyone listens to Paul and to the best practices, I think a lot of companies are going to figure out how to actually organize themselves in order to best take advantage of data. But the thing is, if everyone does it, that basically means data-enabled learning is very unlikely on its own to actually create sustainable competitive positions. And my view is that in order to actually gain something akin to true competitive advantage based on data-enabled learning, you will have to combine it with network effects. So that's why I try to emphasize the conditions under which data-enabled learning does lead to true network effects in which customers do directly benefit from other customers using the same product or service because it improves in the lifetime of their consumption from serving other people like them. So let me stop here, and then hopefully they'll leave some time for Q&A.
Excellent, fantastic. Thank you, Andre. Really, really interesting. We're likely going to run a little bit over today just because we want to have some time for Q&A, so please do stay with us today. Question for you, Andre. I understand that you can't just build a business on data alone. It needs to be much more than that. But I wonder, do you see a point in the future where companies will be able to use data not just as a tool, but a central resource to help evolve things like sales models or customer engagement, supply chain effectiveness, business model change, sort of a lot of different aspects of the business? Do you see a point where we can get to that with companies?
Certainly. I mean, I think this is a little bit closer to what Paul mentioned. I think we're still in the early stages. In some sense, the best practices with data are not very widespread, and a lot of companies are kind of, searching in the dark for what best practices are. And there's a lot of, there's a lot of approximation. I think as companies get better at using their own data, at transacting data across companies, we'll get to, we'll get closer to the efficiency frontier. And I certainly think, the ideal should be exactly what you described, where everything from production, supply chain to customer engagement should be powered by data and should use maximum amount of data, maximum amount of insights from customers. I think we're very, very far today from that, ideal production efficiency frontier, so to speak.
Do you think a way of helping us get closer to that ideal would be, and we haven't mentioned sort of a chief data officer yet on this discussion, sort of the need, the requirement for somebody to sit over this and have the sort of the C-level influence to be able to bring all of these parts of business together? It might be a question for you or Paul, whether you wanted to answer that one.
Sure. I think the new generation of chief data officers that are being minted now are trying to figure out, well, what does it mean to have responsibility for the data? Today, it largely means, it often means risk management and compliance. But for some of these chief data officers, and usually ones that go by the title chief digital officer, they also have the responsibility to figure out how to create new value from this data. And much to Andre's point, I mean, the crucial question here is a strategic one. Strategy is all about creating unique value in a unique way. And so then, the CDO is thinking thoughts about, all right, how can we better understand latent demand among our customers so that we can create new services, so that we can reduce customer churn? How can we use this data to better understand customer segments we have not reached yet so that we can provide value to those groups? But I think the thing that we need in order to really unlock the potential here is a way for CDOs to answer the challenges that come with data trade, that come with facilitating the cross-organizational use of data. And just to give you an example, there's a company called Strand Labs, is an Oracle customer, and they provide analytical services to merchants and banks. And in some cases, they make it possible for a merchant, so a retailer, to create recommendations at the point of sale, whether online or sometimes in the physical world. There's a person with a terminal with a screen there, to make recommendations at the point of sale based on past purchase, but not just that customer's past purchase, but that customer's past purchase in the context of what anonymized aggregates have bought, where those aggregates have some similarity to this customer. Here's the point of all this. The point of this whole story is that the data that makes that possible does not belong exclusively to the bank, and it does not belong exclusively to that particular retailer. These are data sets that are coming from cross organizations. And so in some cases, Strand Labs has a revenue sharing relationship with the providers of that data that make that analytical service possible. Now, this is something that they have set up, by hand with meticulous contract negotiation, and so that all that contract negotiation and licensing of data and revenue sharing and stuff like that, we need a new regime that makes all of that simpler, so that organizations can better trade data assets with each other in order to create value that otherwise would be impossible.
I think you've touched on a good point there. Sorry, when I think about data trade and some of the barriers to that, I do think about this sort of ownership rights, around it, and sort of think about how complex those contract negotiations could be, and whether they may actually just stop people sort of trading in the first place. Are you seeing that happen, Andre?
Yeah, so I think what I was going to add here is that I think that's already very complex. That's why when I said we're in the early stages, is precisely because of that, right? So first you have to figure out, there's a lot of inefficiency still in the trading of data. Now, I would say even once we get past those inefficiencies, we can put contracts in place, intellectual property right protections and so on. We still even haven't touched, well, does that create competitive advantage? If everyone does that, again, I don't think it's necessarily a competitive advantage. If, for example, the data sets that you mentioned, if they're not proprietary, you may feel like as a company, wow, I'm the chief data officer. I did a lot of work. I negotiated these contracts. Okay, we created value. That's step number one. That's great. That still doesn't ensure that you're better than your competitor, because, again, someone else might come and replicate the same contract. So there's still the extra step, which is why, what I was trying to talk about, in which you have to think about, well, which part of this is hard for others to replicate? Now, interestingly enough, you might say that today, because everyone's so inefficient, just negotiating those contracts might provide some competitive advantage. I wouldn't rest and sleep, and sleep sounder just based on that. I think maybe in the short run that might be, but I think you have to think a little bit more deeply what provides true competitive advantage in the long run.
Mm-hmm.
A lot of what we've been talking about today, I think, applies really well to sort of large corporates. I'm sure some of the people who are listening to this webinar are from the smaller SMEs out there who don't want to be left behind in terms of the data economy. Paul, any sort of thoughts, or Andre, on any thoughts on sort of how they need to approach this, whether it needs to be in a different sort of way, and are the tools and the support out there to help them get advantage of this as well, or are we going to see a situation where they're sort of left behind? Do you want to have a go at that, Paul?
Sure. So I think when you think that, all right, so AI requires large amounts of data to train up. That is true. And so therefore, larger companies are going to have an advantage in that sense. That is often true. However, it doesn't necessarily have to be the case. So if you are a niche company, if you're a company that is serving a very targeted customer base, and you have but you have a large, share of the activity, this particular activity that you're conducting with that narrow customer base, well, then you may actually have a large share of the available observations that could be made about the activities of this niche group. In which case, well, you do have a proprietary data set, a data set that would be difficult to replicate because a new entrant would have to go back in time to create it, because you've built up these observations over time. So it's not necessarily a game that is always won by size. However, you do have to think pretty hard about, okay, in what activity or what interaction with customers might you have a dominant share of the observations of those activities in the market at large.
I couldn't agree more with that. Yeah, so I couldn't agree more with that. So, I mean, this is the perspective, I have the perspective of startups. I work a lot with startups, like basically trying to leverage data in creative ways. And, one of the questions that everyone asks startup is, well, how are you going to compete with, I don't know, Google or Facebook or whatever the relevant large company? And the answer is pretty much what Paul just said. It's very easy to be discouraged because you look at these large companies and you say, like, how can I possibly compete with someone that has access to 1 billion customers and 1 billion searches a day? And the answer is, like, oftentimes it's actually like, you don't need all that. Like, you can actually go deeper into a narrower customer segment, and you can learn something really interesting, just for example, by monitoring the usage of a few customers. Now, of course, the key trick, and it's easier said than done, is identifying a niche, like what Paul mentioned, a niche where you can actually have, I don't know if a dominant share, but we can actually be the first one to observe a certain type of behavior and leverage that into data. The other thing that I would mention here is that with data, there's a lot of data that can be bought and sold. So there's a lot of non-proprietary data. There are a lot of non-proprietary data sets. So people just tend to forget this. There's just a lot of data out there which you can use to train your algorithms. So I would say the barrier to entry in like data-intensive businesses is actually lower than most people think. Now, of course, you still have to make a lot of effort. At the margin, you need to like understand customers. But it's not the case that, everyone, like size always wins and you can't enter if, someone's there and has 1 billion customers. Again, think back to some of the criteria I mentioned. You can just find, if you find some data sets that you can buy and you can use that to train your algorithm and then, use a few customers to get some novel insights, you're in business. And from there, it's a matter of like iterating and, coming and trying to, to improve your features before your competitors do.
You mentioned a good point there around you can buy training data to drive your algorithms, and I'm thinking about the sort of the context in which we're living right here, right now, where sort of consumer citizen behavior has changed quite a lot. If you scoot back for sort of a couple of months ago, we're doing things quite differently. What do you think? What is your view on that? Do you think the sort of that data is going to be sticky? Is it going to have value going forward? Or are we during this period of data collection just during an unusual phase where we could sort of largely throw out some of this data and we'll get back to the new normal later on?
So one thought. Yeah, sir. So one thought I have here is actually, you're right. So I think in recent years, consumers have become more sensitive to data issues, and I think there's a high-level push towards owning more of their data, as opposed to the data being the property of the companies that provide services to them. If that happens, if that trend continues, that basically means if I'm a consumer, I'm the owner of my, the data that I generate when I use various services. Actually, so that not only does that empower consumers, but I also think it actually empowers startups or smaller companies, because the consumers can literally, they can take the data and share it with whatever service provider, they like the most. So it becomes a little bit harder for large companies to exclude smaller ones by saying, oh, we have all this data, we're not going to share it. So actually, I think it's more and more likely that large companies will actually be forced, will have no choice but to share their data. Well, frankly, because it's not necessarily their data in the first place, right? It's the data of their customers, and those customers should have the ability to transfer that data to new providers.
Excellent, makes sense. And for Paul, just sort of keeping and thinking about the current situation we're going through at the moment. Obviously, most organizations are operating in a much more decentralized way because we have to. Is this going to have a sort of an impact, a fundamental impact, sort of longer term, on how companies can manage their own data and their own internal data economies? Is it going to be better? Is it going to be worse? Are some of the sort of practices we're seeing now going to be sticky going forward?
Well, I think one of the things we're going to see here is some companies learning the lesson of how to adapt to dramatic supply shocks or demand shocks. Specifically, the change in the data environment that comes from a massive change in the supply situation or the demand situation. We've actually seen situations like this before. I mean, the earthquake and tsunami in Japan a few years ago was a radical supply shock for a lot of consumer electronics and high-tech equipment manufacturers, when all of a sudden the number of their chip suppliers just ceased operating, all on the same day. We also saw this kind of radical environment change with the financial crisis of 2008. So what we are seeing here is that in the new digital operating environment of 21st century companies, they have to learn how to adjust their data structures, their ops environment. So, I mean, the connection between different data centers, between different applications and data tiers, which may be located in different clouds, which may be operating in different availability zones. So companies are really should see what they can learn from executing well in this radically new environment, what they can learn from this for what that means for the way that they change their analytical models, the way that they adapt their AIs when they see big changes in either observed behavior or available data or operating environments.
Yeah, we're seeing here at the Economist, we're adapting quite rapidly as well. We are very much a data-driven company, doing a lot of forecasting, and whereas in the past we would draw on our data and update our forecast really on a monthly, sometimes a fortnightly basis. Now we're having to do it very much on a daily basis as the needle moves, and we're having to adapt. And certainly in the way we're managing our data as well is changing quite a lot. We're a 175-year-old company which sometimes has sort of legacy systems which feel like they're 175 years old now. But so we're very much moving to the cloud. I know we're late adopters, but sort of away from static servers, whether it's in our Singapore or Indian offices. And so I can see from our point of view, we're absolutely adapting as well and changing. So I can see that, and many of those behaviors are going to be very sticky going forward. And so I can see how that's going to sort of be the same case for many other organizations out there. We're running to 1 hour and 15 now, so sort of getting towards the end. I just wondered if you've got any sort of final comments that you would like to share, anything, any advice out there to companies who are need to better position themselves to take advantage of the value out of their this hidden data economy. Maybe we'll go with you, Andre, first.
Sure. I mean, I'll just reemphasize what I mentioned earlier. I think what emerges from this conversation with Paul is I think creating competitive advantage is a very long journey. So it starts with internal processes, actually what you just mentioned at The Economist, particularly for established companies. So it's put your house in order first, make sure you have the right processes. And then you have to take it all the way to the external facing concern is, okay, well, we have our house in order, the production frontier now. Do we have competitive advantage? So let's take a closer look, an objective look, which parts of this data and how does this data enable us to actually do something that our competitors can't, which is the whole, it's the whole set of other questions. And that's what I try to cover in my presentation.
Excellent. Thank you, Andre and Paul.
Yeah, for my part, the idea I would leave you with is that what we've seen with computing over the past 20 years really has been an exercise in virtualization of software, virtualization of hardware, and cloud is kind of the apotheosis of this, the pinnacle of this, where you have this incredible elasticity in terms of compute and storage scale. But the next frontier is to achieve that kind of virtualization, that kind of elasticity with the data sets themselves. And this is the core idea in growing your data economy. It is to reach this point where you've got this data liquidity, where the data is a shapeshifter. And the structure and format in which it is created, you're able to take full advantage of that for the application that creates it, but you are not bound to it for the analytics and AIs where you would like to use it. Achieving this kind of virtualization of data where it appears to any application, analytic, or AI to be, it appears as if it had been born in the format and structure that task requires. This is the next frontier of the kind of virtualization and elasticity that computing has enjoyed on the infrastructure and scaling side. That's where we're going with the use of data itself.
Excellent. Thank you, Paul. It's a nice way to sum it up. And just a reminder that this is such an important conversation, as I mentioned earlier on, the value of the data economy just in the US, and we may get to other markets and try and value it in other markets. But in just the US, we're talking about sort of eye-wateringly large numbers there. So really important to be thinking about this and then positioning your firms to take advantage of this. So thank you very much for your time. Thank you, Paul. Thank you, Andre. It's been a really fascinating discussion. Thank you for Oracle for making this happen as well. For those of you out there, if you have any questions, please do send them in. I'll use the contact button as well if you've got sort of longer discussions you want to chat about as well. But we're here to answer your questions, so please do engage with us. So thank you very much again for your time. Nice to spend it with you, and enjoy the rest of your days.
Thank you, Charles.
Bye-bye now.